Hi, for this video we want to take a look at how the different string distances perform. And so what we're going to do, we're going to take my name, Aaron, and we're going to look at how it measures the distances between different names and my name, Aaron. So the goal of this lecture is for us to get more of a hands-on feel of what we can do with string distances and how they compare to each other. So for this lecture, we're taking the baby names data set from the R package baby names, and these names are coming from the Social Security Administration and the U.S. Census. Okay, so first and foremost, let's go ahead and get some stuff going. What I want to do before I get started, I want to take a look at the number of births for each year, because something I want to keep in the back of my mind as I look at this is that it's not just how many times a child received a particular name, it's also like proportionally how many kids receive that name. So there's two aspects of that. So to keep that in the back of my mind, I want to take a look at the number of births by year in the data set, and we can see that it starts at 1909 and goes on. And now let's do a visualization. So here I'm taking ggplot. So when I do ggplot, I put my data set in the ggplot command. I have the aesthetics layer. Here I'm saying the x-axis corresponds to year. The y-axis corresponds to the number of births. I'm going to make a line plot. And I'm just going to style this as in the black and white theme. That's one that I find that a lot of people prefer over like the default. And then I go ahead and just put a title up at the top so we know what we're looking at. And the title is copied and pasted directly from the help documentation in the baby names data set. Okay, so here we can see that according to census.gov, this is the number of live births for each year. And this will be male and female, where we have a little spike here, like a boom of babies. Now let's go ahead and look at the numbers, but let's break it up by gender. So now here, this data set is coming from the U.S. Census. The next data set is from the Social Security Administration. The numbers will be slightly different, but they're the best sources of data that we have. Once again, I'm using ggplot. I'm putting in the Social Security Administration applicants in the ggplot command, and then year is along the x-axis. N for the all is going to be the y-axis. I'm grouping them by sex, and I'm coloring them by sex because I want two different time series. I want one for males and one for females. Doing a line plot, the black and white theme, put a title on there, and now here I'm going to go pink for girls, blue for boys. And the scale color manual is what I'm doing. When I have scale, then an aesthetic manual, I'm saying, hey, the aesthetic up here, color, is going to receive these values. And here, remember, I have to put the values command in here whenever I use a scale aesthetic manual function. So let's take a look. All right, so something that kind of jumps out at me about this is that earlier in the data set, there were more girls, according to the census, each year. Then they got to be about the same, and then there were more boys following that. So something that might be interesting, something that might be going on, is that it might be that the medicine improved over time so that males were more likely to survive, and in this time span, males are less likely to survive. Possibly that's a hypothesis. I don't know, but it is something interesting to look at. And we can see, we can use the x-axis here to see, approximately when did the switch happen. All right. So now, here's what I'm interested in. I want to see how common is my name each year. Now, something that surprised me is that there are girls named with my name, and I don't mean the ERIN version, I mean the AARON version. All right, so this was something unexpected for me as I was looking through. So I've already learned something about the data. Kind of interesting right there. So what I'm going to do, I'm going to go ahead and take the baby names data set. The baby names data set is, as it's loaded, a tibble. A tibble is a special type of storage format for data. It's in the that's a tidyverse version of data frame storage. I don't really like tibbles that much because I'd rather use base R functions, just because base R works with everything, but tibbles don't always work with every function. And so I always convert everything to the base R version. Also, I learned the base R version first, so I'm more comfortable with it. If you want to go the tidyverse way, rock on. It's a good way to go. All right, so here now, I'm going to subset the baby names data set so that I'm only looking at the times that the name is Aaron. And I'm going with exactly the same spelling as mine. So I'm not looking at the ERINs on this one. And then I do my ggplot. The x-axis goes along year. The number of times is the y-axis. I'm grouping by sex, coloring by sex. It's a line plot, black and white theme. And then I copied and pasted this and then just modified it a little bit. I copied and pasted from the help documentation. Pink for girls, blue for boys. Oh, and I chose deep pink because it appears better. When I was initially doing the plots, I had just regular pink and it didn't show up very well. It's hard to see. All right, so here we can see that in the early 80s, there was a peak in my name. So I was born a little bit before this peak. Then it dropped down. Then it went back up. And it's on the decline. So my name is getting less popular each year. It's too bad. Too bad. I don't know. Maybe it'll be unique by the time I'm an old person. All right, so now let's take a look at string distances. So what I want to do, and the whole point really of this video lecture, is for us to get an idea of how do string distances actually perform and how do they compare to each other. So what I'm going to do, I'm going to compute string distances between my name and all of the other names in that baby names data set. On this line, I'm taking all the baby names. I'm using a unique command because I only want each one time, and then I'm sorting them. I'm just sorting them just so that it goes from ABBA to Z. Now, the method, this is the string distance method, the different string distances that we have, different metrics, and I'm going to compute them. All right, so if you remember from the previous lecture, when we use hamming will work to is only for substitution, and if two words do not have the same number of characters, then what it does, it automatically says that the distance is infinite. And for analysis, that doesn't really make sense. So what I'm going to do, I'm just not going to use it. Before making the video, I ran through this with it, and I decided it was just too cumbersome, so I decided just not to use it. So we're going to use longest common substring, the Levine string distance, optimal string alignment, and then the L. I've got it down below, but the L here is the same as the L here. Q Graham, Jaro Winkler, Jacquard, cosine, and the phonics version. So remember that these 5 are our dist string metrics. So these work on the number of operations for deletion, insertion, substitution, and transposition. That's for these 5. These all use some other format. Q Graham looks at substrings. Cosine looks at, it's a generalization of correlation and looks at the angle between two vectors. And this works on phonics. It converts the letters to phonics, or the words to phonics, and then compares the phonics themselves. If I'm interested in the situation where I want to look at how similar the sound is rather than the spelling, this is the one I want to use. If I'm interested in how similar is the spelling, then I want to use a different one. All right, so now I'm going to go ahead and I'm going to run the computation. So I'm using the sapply function. Remember, sapply, lapply are faster than for loops almost always. And so what I have to do, I'm going to say, hey, take all of the string metrics, for each string metric, drop it into this function. So here the metric is the x. So here I'm creating a new function where this function takes a particular method for computing string distance, and it computes the distance between Aaron and all the baby names for that particular method. And what the sapply function is going to do, it's going to run through all of these with this function. Now, after I get this, it spits out a matrix. There are going to be a row for each baby name, and there's going to be a column for each distance metric. And so I go ahead and take the baby names and assign it to row names, and I assign column names to be the string metric. So now let's take a look at what does this look like. All right, so for longest common substring, for Levine-Schustein distance, OSA, optimal string alignment, and then DL is Demirel Levine-Schustein distance. Remember that these are counts. These count the number of operations to make one word into the other. And so these are numbers of counts. Then over here I have Q-grams. I have Jaro-Winkler distance, Jacquard, the cosine of the angle between the vectors, and then phonics. And the phonics, when I looked at it previously, were just 0 and 1 all across the board, which isn't very interesting for this. All right, and so just to remind ourselves what these are, Hamming is only doing substitution. Longest common substring is just deletion and insertion. LV is deletion, insertion, substitution. OSA is deletion, insertion, substitution, and transposition. But transposition can only occur once. And then the full DL distance is all 4 operations as many times as needed. All right, so now let's go ahead and take a look at the correlation between what we get for the metrics. And not surprisingly, the metrics that are the dist, the ones that are most similar to each other have the strongest correlation. Not a big surprise. Now, this table is really hard to read, and so what I want to do, I want to visualize this. I want to actually see what's going on. So I'm going to go ahead and use ggplot from the ggplot package. All right, so what I'm going to do a correlation plot. A big dark circle represents stronger correlation. A small faded circle means weak correlation. And what I'm going to do, after I take the correlation, I'm going to order them by the order in which they would appear in the plot for a Ward D hierarchical clustering. So order is hierarchical clustering. Method is Ward D. Remember that Ward D minimizes the standard deviation in the cluster, and it's good for having clusters of closer to equal sizes. All right, so here we can see that our dist metrics are all grouped together along with Q-grams. That's kind of surprising. I didn't expect this to happen. The phonics one is by itself. And then over here we have the other more mathematical metrics in a group, which is kind of interesting. So first of all, these correlation plots are nice because I can visualize the correlations, but also when I organize them using the hierarchical clustering, I can see which ones group together very, very quickly. So here I would say there's probably like 3 clusters among the distances. Now let's do this again, but now let's do single linkage clustering. All right, so right off the bat, I can see that the one for phonics is off by itself. It's its own cluster again, but it's positioned differently in this one, and then we have the same ones, the same 3 coming together, and then we have the rest of these coming together also. Pretty much the same result, but different ordering. All right, so now let's go through and let's find the 10 names that have the most similar spelling to mine. And let's create a time series for each of these. So what I want to do, I want to see, are there, like, back in 1920, was there a different spelling of Aaron that was more popular? What was that spelling? And I want to see, are there any names that are up and coming? So in the future, am I going to have to, introduce myself to people named Aaren or Aarin, something like that? How is Starbucks going to misspell my name in the future? Let's see. Let's find out. So what I do, I take the vector of names, and I'm going to reorder them by the string distance computations. Now here I'm using the DL operation. I went ahead and chose the metric that has distance, insertion, substitution, and transposition as many times as necessary. That was just a personal choice. I could have picked another one. If I was more interested in how the phonics would be, I would put sound X here instead. I'll get different results depending on which metric I choose. And I'm just picking, so after I've got this, I've got it sorted so that the very first one is going to be the name Aaron, the way I spell it. The second one is the second most similar spelling. The third is the third most common spelling, and so on. Now, for this, I'm really not interested in the female names, just because, when I looked at them previously, there really weren't a whole lot of Aarons with my spelling overall. So I went ahead and just, only considered the males for this. Now let's go ahead and make the plot. So once again, I'm using ggplot. I've got a static layer where I've got year along the x-axis. N is corresponds to y-axis. I'm grouping by name and coloring by name. It's going to be a line plot. It's a black and white theme, and then I'm doing a title. Now you'll notice I've got a subtitle here. In my subtitle, I'm saying males only, and the reason why I'm doing this is so that when people look at it, they realize that any females in the data set were not considered at all. Alright, so let's take a look. So first and foremost, we can see that Aaron is by far the most common. And now for all these other ones, all these other 9 names, Aaron, Arion, and so on. I feel like I'm in a Key and Peele video. All of these put together really do not amount to very many children at all. Now, something about this data set is that any name that appeared less than 5 times in the data set was excluded from there. So there could be other names that are more similar to mine floating around, but they were in the data set. If it's like only once or twice or 3 times, those counts were excluded. I hope you're staying healthy in this time of coronavirus. Take care and have a great day.